Warkworth wastewater treatment plant is near capacity. Local aquaculture can't risk further discharge from expansion of treatment facilities into the Mahurangi River. Current thinking is to expand facilities at Snells Beach, pipe Warkworth waste to this expanded site and extend discharge piping out to sea. This is all estimated to cost $150 million and probably more than a decade to execute. Given that Warkworth is targeted for a 5-fold population growth in 2 decades, and that expansion can't start in earnest until this facility is complete, following conventional means of wastewater treatment precludes the larger goals and sits in it as a mammoth supply-side constraint in the face of huge demand for housing for the area. Our vision includes distributed wastewater treatment. We favour the Cinderella incinerator toilet, in combination with reverse osmosis treatment of grey water at this stage of my investigation. 2 or 3 toilets can be afforded for the savings made by not connecting to the reticulated community-wide system. A biological system such as that offered by Eloy Water is also suitable for small lot development. A couple of 100 square metres is all that is required to disperse the output from such a unit. A subdivision-wide energy cogeneration wastewater system where the outputs are clean drinking water and electricity have their appeal, but don't fit with our current financing model and decrease the resilience across the system. Any one of these distributed systems could replace the $150 million spend currently proposed. Effectively, instead of an upfront capital cost requiring financing with inherent interest charges, each new residential or commercial building builds out the wastewater infrastructure, exchanging development contribution fees with a technology spend in each property. Admittedly, if we go with an incineration system at Blackwater, we are left with grey water to contend with. A system such as this copes with much of the issue. Water from the kitchen sink and dishwasher need to pass through a grease trap prior to entering the grey water recycling system. If the output from this system passed through reverse osmosis filtration or compressed vapour distillation, the resulting water would be drinkable. Unfortunately, we don't think the market is quite ready for that degree of recycling just yet. At this stage, we anticipate reuse in a drip feed irrigation system and for clothes washing. We plan on recovering some of the energy involved in disposing of Blackwater waste using the hot water system. To more than offset the loss of food production capacity of rural land converted to urban development, we intend to produce protein in the form of fish and carbohydrates in the form of vegetables locally on each plot of land. These will be centrally managed and controlled, requiring no intervention by the homeowner. Potable water from rain can be collected and stored and made pure through a whole-of-house inline reverse osmosis filter system, possibly in combination with inline ultraviolet treatment. Water can be pumped from artesian sources in times of low rainfall for additional resilience of the system.